Okay, we're looking at the distance formula. Right now, we're going to do this together. It's being recorded currently. You should be working on this right now.
Okay, right now. It's upside down at the moment, so wait a second here. Okay. Okay, so here we go. So let's just look at number 1, right? It says use the Pythagorean theorem to find the length of the missing sides for each of the following triangles. What's the Pythagorean theorem? Do you guys remember?
Yeah, I remember, but I forgot.
A squared plus B squared equals C squared.
Thank you. Okay, so I'm going to write that down right here. A squared plus B squared equals C squared. Okay, so this X right here, is this an A, a B, or a C? That's an A?
No, C.
That's a C, right? Because the long side is always C. Good. So for this one, our formula is going to be 5 squared plus 12 squared equals X squared. Okay, you guys good with me so far?
Yeah.
Okay, so this should be 25 plus 144 equals X squared. And then, right, how do we get X by itself?
Minus 25.
Well, right, to get X by itself, we got to take the square root of both sides, right? So this, first of all, this 25 plus 144 is going to get us 169 is equal to X squared. And so we got to take the square root of both sides. And so we should get X is equal to 13. Okay?
Oh, yeah.
Good. All right, so B, right? Which is the C in this one? Which one is the C? 5. Good. So we've got X squared plus 4 squared equals 5 squared. So now what do we do? Square them out? Okay.
What you do is,
Okay, so we should have X squared plus 16 equals 25. Then what? Then you get X by itself. Good. So you got X squared is equal to, and then we take 16, or take 25, subtract 16, should get 9. And then to get X by itself, we take the square root of X squared and the square root of 9.
3.
Good. X equals 3.
Noise.
Okay. One more. Which one's the C on this one? 40?
X.
X.
now.
Look at this. It's the diagonal one. It's the long diagonal one is C. See? Long diagonal one. Okay, so we've got 40 squared plus 9 squared equals X squared. Okay, 40 squared is I think it's 1600. So we've got 1600 plus 81 equals X squared. Okay, 1600 plus 81 is 1681 equals X squared. And then we got to take the square root, right? Which would be X equals 41. Does that make sense? Okay. So for number 2, it says plot the points 2, 3, and 6, 9 on the coordinate plane. And then we got to connect the 2 points with a ruler. So you don't need a ruler, but like if you have a piece of paper, like fold it in half and use it as a straight edge or something. But why don't you do that right now? Okay, so we've got 2 over 3 up and 6 over 9 up. Okay, and we're going to connect this line. Just like that. Okay, so then it says draw the slope triangle for the segment connecting the 2 points. Now, a slope triangle, you know what that is?
Yes.
Okay. Good. So I'm going to draw it. I'm going to draw it too. So I'm going to do this many up and this many over. Okay? So number 3 on there, it says, what special triangle is the slope triangle? Anybody know? What kind of a triangle? Maybe this will help. A right triangle. Good. And based on what we did above, what do we know about what can we do to right triangles to find the side length here?
You can flip, what's it, something you can flip it like a mirror? I don't know.
It's okay. Well, what you can do is you can apply the Pythagorean theorem. Right? And then since this is the C, right? We can find this distance using the Pythagorean theorem. Okay? So number 4 says, what part of the triangle represents the distance between the 2 points you plotted? Should be the hypotenuse. You guys remember that H word? Hypotenuse? Okay. Hypotenuse. Okay? And then it says, use this information to find the distance between the 2 points. So here's what we should have. We should have a height of 6 and then a length of 4. So what do we do with that 6, the 4, and the x here? We did it above. Pythagorean theorem. Thank you. So we're going to do, I'm going to do it over here to the left. 6 squared plus 4 squared equals x squared. Okay, then we multiply all that out. We should have 36 plus 16 equals x squared. Okay, 36 plus 16 is 52 x squared. Okay, and the square root of 52, right, because we got to square root the x, so we got to square root the 52, should get something like x equals 7.2. You guys following there?
Yeah.
Okay, so x equals 7.2. All right, for number 3, right, we're going to do basically the same thing. Okay, so let's do that together. We're going to do negative 2 over, negative 3 down. Jalen, stop talking back there. I know, but I hear you talking like the whole time. I'm trying to record here.
All right, I'm just gonna tell us one. You said I know.
Okay, here we go. We go 8 over and then negative 7 down. So 1, 2, 3, 4, 5, 6, 7 down. Okay, we're going to connect that line. Connect those 2 points. Okay? Good. So we're going to make our right triangle again. Okay, should look something like this. Okay? And now we're going to find the distance again. So this height right here is 4. And this is 6. So we could probably skip the math here, right? Because it's going to be the same triangle that we did before, right? So we're going to have this 6 squared plus 4 squared equals x squared thing. And so it was the exact same thing that we did last time. So x should be 7.2. Okay, everybody good there? All right, let's flip over to the back. Okay, we've got number 4. It says plot the points negative 2, 6, and 3, negative 5. So we're going to go over negative 2, up 6, right there. And then we've got 3 over, negative 5 down. So right there. Okay? And then you've got to draw that line between the 2 points right there. Okay? Again, this sounds like what we did already. We're going to make the triangle. Okay? So Hopefully that's what you have so far. Okay, so we've got the base is 1, 2, 3, 4, 5. Okay? And we've got a height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right? So we're going to apply the Pythagorean theorem, right? So we're going to do 5 squared plus 11 squared equals x squared. Right? 5 squared is 25. 11 squared is 121 equals x squared. Okay, then we're going to add these two, right? So we should get 146 equals x squared. And then how do we get x by itself? Take the square root. Good. So we're going to take the square root of this one, take the square root of that one, and we should have 12.08 equals x. Okay? Not too bad? All right. Here we go. We've got another one now. We've got one more, and then we've got to write a formula, and then we'll be done, and you can do the homework. Okay? So we got to plot the points. 3 over and 8 up, right there. And 10 over, negative 2 down. Okay? We're going to draw this line. Should have something that looks like that. Okay, you don't always have to draw your slope triangle, but for some people it helps. So I'm going to continue to draw it. Okay, so our base here is 1, 2, 3, 4, 5, 6, 7, and our height is 10. Okay, so I know this is the same thing that we just did, but we're going to do it again. 10 squared plus 7 squared equals x squared. Okay, then we've got 10 squared is 100 plus 7 squared, which is 49. Okay, equals x squared. So we've got 149 equals x squared. And then we get x squared by itself by taking the square root. Good. So we've got x equals 12.2. Is that what you said, Jalen? Yeah. Nice. Yep, 12.2. Perfect. So x equals 12.2. All right, now this is where this part is very important here. We got to use your answers to write a formula for finding the distance from A, comma B to C, comma D. Okay? Now I know you're thinking, how do I find length if it's just or if it's just letters? Well, we got to plug it into the formula. Okay? So here's what we're going to do. We're going to make some just random points. Okay? For A, B, and C, and D. Okay? So I'm going to put a point right here, and we're going to say that this point is A, comma B. Okay? Because we'll call this A over, and we'll say this is B up. No, it doesn't have to be exactly the same. It's going to turn out the same regardless. Okay? And then I'm going to put CD down here. And put it down here. Okay, so this is C, comma D. Okay, and the way I know that right is this is going to be C units over and D units down. Okay, are you hanging in with me here so far? Okay. So, I'm going to draw a line between them. Now, the reason that I drew these things on here, hopefully you can see it right there, okay, is now we're going to make a triangle with this thing. And I want you to look here and see, okay, so the height right? See how this distance right here is D? And then this distance right here is B. So the height, this height right here should be D plus B. Did you guys see that? Right here is D, and right this height is B. So we just added those two heights together. Is that okay? Okay? And then this length right here, see how this length is C? And then we've got to add an extra A. So our length should be C plus A. Okay, so what did we do? What did we do with our two side lengths before to get the answer? You remember this? We plugged them into the Pythagorean theorem. We plugged these two legs into the Pythagorean theorem. Good. So we're going to do the exact same thing. We're going to plug in the leg D plus B, okay, and then the leg C plus A into the Pythagorean theorem. So we've got D plus B squared plus C plus A squared equals x squared. Okay? Now we just have to find what x is by itself, just what x is. So how do we do that? How do we get x by itself? What did we do up here? Took the square root. So we're going to take the square root of it, right? Because when it's x squared, you want to do the opposite, right? And square root it. So we're going to take the square root of this, take the square root of this. So x equals the square root of D plus B squared plus C plus A squared. And this right here is the distance formula. Okay? This right here is the distance formula. So you won't have to draw it anymore if you don't want to. So we can give you two sets of points, right? Like 1 and 4, and then 6 and -3. Okay, and then for A, you'd plug 1 in right there. And then for C, you'd plug 6 in right there. That making sense? Okay.